Alrighty, so this is for 7.3. We're going to cover 1 through, I don't want to say the wrong number, 5, okay? So we're going to do 5 questions, and then we'll be done, okay? Before we start, we need to look at this little chart. I separated it into 3 because I thought it looked nicer. But if you look at your printout notes, you'll see it all in one table, okay? So essentially you're looking for the form in this red, and if it's in the red form, then you use what's in the black box, okay? So for example 1, we're asked to integrate this expression right here, and you can see that it is in this form. That form is this first one, so we know that first thing that we need to figure out is what our a is. So our a right here, 1, is how do you say 1 as something squared? That'd be 1 squared. So our a is 1. And then from there we can figure out what our x is. So in that case our x would be 1 sine theta, or just sine theta. And then once you have your x, you can find your dx, cosine theta, dx. And then from there, what's happening is we're about to change it from x to theta. So remember, whenever you're changing your variables on the inside, or what you're taking respect to, you also have to change your interval. So originally we had it between 0 and 1, and now we're about to change it from x's to thetas. So we need to take this equation right here that incorporates x and theta and plug in our values. So we plug in 0 for the first one, and we get theta is 0, and we plug in 1 for the second one, and we get theta is pi over 2. So now our new interval is from 0 to pi over 2. Okay, so instead of 0 to 1, we have 0 to pi over 2. Instead of x cubed, our x is now sine theta, so we have sine cubed. And then on the inside here, instead of x, again, that's going to be sine theta. So that's why we have 1 minus sine squared theta. And now instead of dx, we have cosine theta dx, okay? So we write this entire thing, and we're good. Just remember, when you're working these problems, you don't want to have mixed-match variables in between. So if there was still an x left, you need to make sure that you change it, especially before you change the interval, okay? Next, we are going to use our little chart. So again, we're looking at this top one. So we've used this information. Now we're going to be looking at this. So we know that cosine squared is the same thing as 1 minus sine squared, which is awesome because it actually showed up in our equation. And remember, we work specific problems within this course, so you'll be able to do that, okay? So we can change this to cosine squared because of our little box over here, and go from there. Squared and a square root cancel each other out, so this will just be cosine, right? This entire thing right here would just be cosine, and then cosine times cosine gives us cosine squared, okay? And then from here we go right back to the previous section from 7.2, where we did like the whole even odd sine cosine thing. And you can try that. If you're working it and it doesn't work out, that is completely okay. So like in this case, we're here from 7.2. We have odd sine, so that means we could use this top one, right? It doesn't look like I used that one, but I did previously.